can you imagine air coming out? It is going in diverging beam, so it spreads out. But my experiment depends upon the flow of one direction air. Okay, I want focused, so I attach one pipe, and on this pipe, oh. Can you imagine what is happening? My fingers are lifted up because of air pressure. So on this air flow, if I keep the ball, what will happen? I'll leave it. What will happen? The ball will go up. How much it will go up? 1 meter, 2 meter, ceiling height? No, not ceiling height. And if it will go up, will it remain there or it will fall down? Why it will fall? Gravity. Very good. But I will show you magic. It is not falling. Surprisingly, the ball is going up. It is bit heavy weight. If it is lightweight, it will go more up, more and more height. But this ball doesn't fall down. Now students ask the question why the ball doesn't fall down. And I give the answer. Actually, the answer was given by a genius scientist called Daniel Bernoulli. Daniel Bernoulli, master in fluid mechanics, he gave the answer. What he explained, the ball is standing here because its weight is counterbalanced by the air pressure, velocity of air, okay, force of air. But question is why the ball did not fly away this way or that way or any direction. And he explained very simple logic. Suppose the ball is here and ball tries to go away like this. In that case, the speed of air here is high. Velocity here is high. And here velocity is less. So here air pressure will be less. And here comparatively air pressure will be more. So what will happen? Surrounding air will try to push the ball back to the center. Now if the ball tries to go on this side, what will happen? From this side it will push. Common sense. This is science. If the ball tries to go in any direction, surrounding air will keep on pushing the ball towards the central maxima line. Now you can ask me question, what is central maxima line? Central maxima line is the axis of this pipe. या पाईपचा अक्ष आहे ना तो सेंट्रल मॅक्झिमम आहे. हा ग्राफ असा येतो हा प्रेशरचा आणि इथे तुम्हाला बॉल स्टेडी मिळतो. यू आर गेटिंग बॉल स्टेडी. आर यू गेटिंग माय पॉइंट? राइट. नाउ क्वेश्चन इज इफ आई कीप अनदर बॉल and make it on. Oh, fine. It is going on. Now question is, ball is floating here and if I make the pipe bend, change the angle, what will happen? The ball will come here. But will it remain here? No, it will fall down. Yes or no? Yes. It will fall. Okay. Common sense, right? But sometimes common sense becomes nonsense. You know why? Magic. I brought the ball from here to here and then I brought it back to center. Without any thread tied to the ball, I am having the ball shifted here back. That is very important. Now people will ask the question, why the ball did not fall? Why the ball did not fall down? The answer is Bernoulli pressure. Because of airflow, surrounding air will keep on pushing the ball towards the center maxima line. Very simple statement, and everybody should understand that the ball did not fall because it was trapped in the air. Simple word, it was trapped. Now further interesting thing, if I make the angle more and more and more and more, and if I bring the ball here, will it remain? No, it will not remain, it will fall. Why it will fall? Because the weight of the ball will dominate over Bernoulli pressure. Can you imagine? Yes, let us work out. Yeah. What did you observe? I went on increasing the angle, and after one critical value it fell down. Very interesting. You have to think why. But I will not waste my time. I will give you some more magics. Okay? This ball is suppose stationary here. And when it is stationary here, I play mischief. I switch off the motor. When it is stationary here, equilibrium, I switch off the motor. What will happen? The ball will fall. I will give you three options. The ball will fall. How it will fall? One thing, it will fall by projectile motion and it will go like this, number one. Option number two, the ball will have vertical fall. Option number three, the ball will fall towards the pipe. Now some students are responding. I like those who respond. But I want to take opinion poll, public opinion poll. Very simple. First option, the ball will be thrown like a projectile towards that side. How many agree with me? Raise the hand. Nobody agree with me. Huh? Nobody agree. Okay. Now second option, do you agree with me? The ball will fall like this. Okay. Okay. Second option, the ball will have vertical fall. How many agree with me? Oh, great. Good. Very good. So, large number is agreeing with me. The ball will have vertical fall. Okay. Hand down. Third option, the ball will fall towards the pipe. How many agree with me? Some people are raising the hand 2 times. Very smart. Okay. Some people. Okay. So now what is the answer? Answer is workout. Okay? Did you observe what happened? The ball came back to pipe. Oh God. Now my question is why the ball came towards the pipe? Why the ball came towards the pipe? Why it did not have free fall, vertical, towards the earth? It came towards the pipe. And the answer is very simple. The moment I switch off the motor, it doesn't stop working. Its RPM goes on decreasing gradually. Maximum RPM is 16,000 rotations per minute, 16,000. From 16,000, it comes gradually, slowly down, and as it goes on decreasing, the pressure goes on decreasing, but the ball remains trapped in the air blue. And that is Bernoulli. The ball remains trapped. in the air flow, and that is Bernoulli's theorem. Very simple. Okay. Now some people ask me, will it be the same story with this ball also? Let us work out. That is the best. So I will try here. Okay. It came down. It came down towards this. Fine. Now, interesting thing, I keep this ball, switch on. Okay, this ball, I switch on. Fine. That's fine. Now, if I keep this and then this, it will not work. It will not work. Want to see? It doesn't work. Okay. But if I keep this and this, then it will not work. Do you know why? Very interesting. Why? You have to find out why. But first you observe, this ball will attain some height, and this also will attain some height. And if they are trying to get same height, they will keep on fighting for the same place. Switch on. Okay, fine. Now, what is this? Something wrong with this ball? Heavy mass. You're right, heavy mass. Now, let us start with this ball. Quite surprisingly, this ball goes to very, very large height, but it cannot remain stationary. You have to think why it cannot remain stationary. It is lightweight, small size, correct? It is lightweight, it is small size, but I show you magic. See? No, it cannot remain stationary. It goes to high level and it falls. Very interesting. Okay. Now let us take another interesting ball, and this will show you what spinning motion. You can see the spin. Now if I take the two balls and they are of same size, same mass, same weight, same density, same diameter, you know what we call them? We call them identical twins. They are the identical twins. And if I keep them one by one, they will try to attain same height. But if I keep both simultaneously, what will happen? They will keep on fighting. You know? You want to see the fight? they will try to attain the same position. But same position, air will go in between and separate the ball, one will fall down. Okay, that is common sense. Now this ball, very critical. This ball has a very rough surface. This ball has very rough surface. You know what is this? Like gold ball. And this ball cannot attain equilibrium. It cannot attain steady state. For example, this ball can attain steady state. See, you can see. Slowly. Okay? How they are practicing this? But this ball cannot attain steady state. Oh, have you seen what happened? This cannot remain stationary. You know why? Because the air will have lot of friction and will keep tangential force applied. So it will keep on wobbling here and there. Surface is also very important. Okay. Now those who want to study more and more, I got one funny experiment for them. And it is like small research. Huh? You see this ball? Yes, what is this? Crazy ball. Hey, heavy, solid. And you know what is this? 1, 2, 3. Big size, medium size, small size. Can you see the size difference? Yes. Now see the fun. I keep this ball and switch on. Goes on. I keep this ball and switch on. It doesn't. Then I keep this ball and switch on. It goes on. This is surprising. The bigger one goes up, the medium one does not go up, and the smaller one goes up. What can be logic behind it? Very simple. For that, we have to see what is this pipe. This big size ball has more area of cross section, so sizable pressure is built up. Air pressure is built up because of area and volume. But this medium size ball, the moment it is lifted up, the air will escape out and not sufficient pressure to lift it up. But this small size ball, when I keep inside, it will go and block the pipe. So blocking the pipe means building the air pressure. And because of the air pressure, it is thrown up. And once it is thrown up, it remains up. You can see. Once it is thrown up, it will be remaining up. Now, one more funny experiment. I have got a tea filter ball. I keep the ball in tea filter. It remains stationary. But if I keep the ball like this, will it remain? No. Why? Why will not remain? It is spherical ball and is convex surface. So the contact is very small point and the ball will start rolling down. You know, rolling motion. And it is because of gravity. But I will show you magic. You can see. See the ball. See the ball. Fine. The ball remains stationary. Tell me why? Bernoulli pressure. You know, the air goes through holes and will create Bernoulli pressure from sides. That is the essence of the experiment. But point to be noted, I am giving support to this ball. That means my hand is providing normal reaction for balancing the weight of the ball. That is very important. And that is why the ball was remaining stationary. Otherwise, it would have wobbled and it would have fallen down. Okay? Did you like the experiment? Very good. All of you, within 1 minute, change over, stop talking. This is very, very famous pioneer experiment in physics. Very basic, Newton's Cradle. It explains conservation of momentum and kinetic energy. M into V, mass into velocity, momentum. And 1/2 mv square is kinetic energy. And how it works, you see. I take one ball away to some height and leave it free. It goes down like pendulum. But when it goes down, when it is lifted up, it has got energy called as potential energy. And when it goes down, it will attain kinetic energy and momentum, right? Kinetic energy and momentum. So what will happen? It will go and hit the 4 balls. Can you imagine what will happen after hitting the 4 balls? Only one will get kicked out. Okay? Only one ball will get kicked out. And you can see it is perfect balance of momentum and kinetic energy. Okay? Fine? Check out. Observe this. Now, if I take from this height, that will go to same height. That also is balanced, counterbalanced. Now, I take 2 balls. What happens? The 2 will go. Now I take 3 balls. Now I take 4. Now I take 1 from this side and 2 from this side. Now what will happen? 1 and 2. So 1p and 2p. Momentum, 2 momentum. What is the net result? 1p in this side, correct? But it is wrong. Because in this, energy is not conserved. To conserve the energy, we require 3 balls in motion. So before collision and after collision, stop talking. Come and sit here somewhere. Don't stand, please. Sir, I don't like people standing. Please. Okay. Now I take 1 from this side and 2 from this side. What will happen? Oh, very interesting. When I say 1 from this side and 2 from this side, after collision, one will go this way, 2 will go this way. You know? Like penetration, momentum. But after coming back, they will have 1 to 2 1 exchange. That 1 to 2 1 exchange is very important. Okay. You are getting exactly 1 to 2 1 exchange. Now question is, if I take 1 from this side and 1 from this side, what will happen? Both will go and hit and come back. But 3 in the center will not move at all. See that these 3 are remaining almost stationary and only 2 are banging. Now question is, why these middle 3 are not moving at all? And the answer is very simple. F1 and F2. These 2 forces are equal and opposite. What is the net force? Net force is 0. And now Newton's first law says that if there is no external unbalanced force acting, there is no motion. The body will remain stationary. So basic concept of Newton's first law is clear by this experiment. Now if I take 2 from this side and 2 from this side, what will happen? The middle one will not move at all. Now why middle is not moving? Because no external force acting on it. Unbalanced force is not there. Fine. Very basic property. Now, suppose I remove the 3 balls and keep only 2 in picture, and I take 1 to some height and leave it. What will happen? Yes? This will go and hit this ball. After hitting, what will happen to this ball? What will happen to this ball? It will stop. It will stop. And this will get out. Want to see? Very interesting. See, this will come and hit and stop. Very interesting. Hit and stop. Not hit and run. You know what is hit and run? Some people make the accident and run away. That is not in physics. Huh? In physics it is hit and stop. You see? Check. Okay? Now question is, why the ball will come and hit and stop? Newton gave the answer. Very interesting. Newton gave a very simple concept. That concept says that this ball will transfer all its momentum and all its kinetic energy to other ball. Are you getting my point? Transfer of momentum and transfer of kinetic energy, and that also is 100%. Very difficult to understand how 100% energy and 100% momentum is transferred. But he explained why this happens, and he gave the answer because the 2 balls have equal mass. You know what is equal mass? Inertia. Inertia property. Yeah. I always ask this question to our young people and they give the correct answer. Let me see how many of you are giving correct answer. Suppose I got a very heavy ball, stationary, and one light ball will come and hit the heavy ball. Tell me what will happen? Lightweight ball will come and hit the heavyweight ball. What will happen? Okay. Anybody want to answer my question? Raise the hand. Okay, nobody raising the hand? Alright, I will give the answer. This ball will move a little bit, but this ball will go back. Are you able to imagine what I am saying? Other hand, other way around, small ball and big ball. Big will come and hit the small. What will happen? The small will go far away. And what about big ball? It will hit and stop. Or it will continue. Or it will go back. Hit and stop. No, not hit and stop. You know, hit and stop applies in equal mass case. Basic concept. Lightweight, heavyweight. Heavyweight will come and lightweight. Lightweight will go far away, but heavyweight will continue to move in the same direction for some time. You know why? Mass. Here comes the concept of mass. Heavyweight will not stop, but continue. I'll give example. How many of you have played carom? Yes, many, almost everybody. Fine. Very good. Did you observe that sometimes in carom, when you hit a coin by striker, coin goes into the pocket and striker also follows into the pocket. Tell me why? Mass. What is mass of the coin? Mass of the coin is 5 to 6 gram. And what is mass of the striker? 15 gram. Oh, it is very heavy, 3 times heavy, 15 gram standard striker. And coin is about 5 to 6 gram. So, understand, it is mechanics, it is physics. in carom and every game. Anyway, now I'll ask you another question. Very difficult question now. Suppose I take both the balls to some height and leave them simultaneously. What will happen? They will come and hit and stop. Yes or no? How many say yes? Raise your hands. Okay, how many say no? Raise your hands. Good. Large number is saying no, and some number is saying yes. Let us work out. Oh God. See what happens? See what happens? Very interesting. The balls are keeping on banging, hitting, non-stop. You know why non-stop? Momentum energy conservation. But if you are scientifically good observer, you will find that their distance is going on decreasing. Check. The distance is going on decreasing, and after some time they will stop. Now I will use the logic behind it, science behind it. When they are hitting each other, they are losing some energy. They are wasting some energy, losing. Now in which form they are losing the energy? They are losing the energy, number one, in the form of sound energy. Did you hear sound? When they are banging, they are making sound energy. Second thing, when they are moving through air, they have to overcome the viscous drag of air, friction with air, and to overcome this air opposition, losing some energy. And the third loss is there, which normally people don't understand at all, and that loss is when they keep on hitting, some thermal energy develops. They become hot. They become warm up. Very difficult to imagine, right? But thermal loss is there. Now my question is, if I keep this apparatus in a glass box, airtight, apply vacuum pump and remove all the air, make clear vacuum. Can you imagine vacuum around this glass transparent box, and by some external mechanism I make these balls to collide. Now in vacuum there is no sound energy. You know why? Vacuum, you will not get sound because no air, no vibrations. Second thing, there is no viscous drag opposing the motion. So what is the question? This collision will continue forever. Yes or no? Yes, it will not. It will be non-stop. Okay? But the answer is wrong. Answer is wrong. You know why? When they keep on hitting, some thermal energy will be developed. And that thermal energy can dissipate without medium also. In vacuum also it can dissipate. Okay, very difficult thing. But in vacuum it will take long time because losses are minimized. Okay? See the distance slowly decreases. This slow decrease is called as exponential decay. Exponential decay. And that is very important. Okay? Exponential decay at higher level, you'll learn this very special in physics. Okay? Now, we have done some observations, but now I'll show you some events. I'll show you events, but I'll not explain science behind it. You have to explain yourself. You know, you have to explain yourself and give the logic behind it. Start with the event. Number one, two are stationary, one will come and hit. What will happen? One will go out. You see, two are stationary. Now, one is stationary and two are hitting from both sides. Okay. Now, I take one from this side, two from this side. What will happen? Oh, great. Have you seen what happens here? 1 to 2, 1. Exchange is there. Fine. So always we get very interesting phenomenon. Now 3 are stationary and one will come and in. What will happen? Observe. Now two are stationary and two will come and in. What will happen? Oh. You know it is hit and stop. Have you seen? Hit and stop, mass equal. 2m to n. Now one is stationary, 3 will come and in. Now two are stationary and two are hitting from both sides. The middle are not moving at all because they are having balance force, right? Now two from this side, two from this side. Very simple. Every time, remember law. Conservation of momentum and conservation of kinetic energy. Okay? Now, I take 2 from this side and 3 from this side. Have you seen? 2, 3, 3, 2. Very easy. Now, very nice. What you observe? Multiple collisions. Fine. So I make one statement that these balls are clapping for Sir Isaac Newton. But I had done already clapping. Now people like to see the magic, and I got plenty of magic. Okay. Now this ball is magic ball, and it will float in air. See, the ball is floating in air. You know why it's floating in air? Why is it floating in air? Yes. What can be reason why it is floating in air? Magnet. Where is magnet? Where is magnet? In the ball or in the stand or both? Both. Why both can be magnet? No. Why not? Unlike pole. That is sad. Unlike pole. Now I got my keys, iron. I bring the keys near. What I observe? Stuck up. What does it mean? Magnet. But wrong statement. It can be iron and this can be magnet. You know what is attraction is not the criteria. The criteria is repulsion. Understand? They are getting attracted. It doesn't prove that it is magnet. This can be magnet, this can be iron. So no guarantee. But here also they are getting stuck up. That means there must be magnet. Again, this can be magnet, this can be iron. So again no guarantee. But these two are getting attraction. That means guarantee is that one of them is magnet. You are able to understand what I say? My statement is very clear. At least one of them must be magnet. But I can't say both are magnets. Because attraction doesn't prove magnetism. But I don't need keys to prove that both are magnets. Because I can use my logic. What is the logic? Suppose this is North Pole, magnet North Pole. What should we pole here? And what should we pole here? I bring north near north. What will happen? Something different. See what happens? The ball is going like conical pendulum. You know why? Repulsion. That means this pole and this pole are repelling each other. What does it prove? It proves that both are magnets. Both are you getting my point? So remember the statement. repulsion is the sure criteria. Okay? Fine. Now let us come to the higher level. Let us come to junior college level. Yeah, people say, "Oh, we don't want junior college level experiments here," but I say that in childhood, if you see such experiments, you will enjoy learning higher level. I got plenty of materials here. You can see several materials are there, and every material is different. Now, what is this material? It is a cardboard, simple, one side plastic coated. I pass it in the gap. What will happen? If I pass it in the gap, the ball will fall down. Why did it fall? Because this will cut the lines. Yes or no? Yes or no? Okay, some people say no, I think. Okay. See what happens? Doesn't fall. You know what I am proving? I am proving that this medium is transparent for the magnetic lines of force, for the magnetic field. Now I take thick cardboard, very double thick, cheese box wrapper, and pass it. Oh, transparent. Now I take very, what is this? Bakelite sheet, hard plastic, bakelite, and pass it. Again, transparent. Yeah, very nice experiment. Now I take a thin foil of aluminium, metal, and what will happen now? If I pass the metal, it will fall because this metal will cut the line. But wrong answer. It doesn't fall. And why it doesn't fall? Because it is aluminium. It is not ferromagnetic. It is paramagnetic. Very weak property. So it doesn't fall. Now this is a multiple layer foil. 8 layers are there. Fold, double fold. And I pass it again. Transparent. Now I take a thin plate, metal plate, and pass it. Transparent. Now I take a glass sheet, glass plate, plain glass. Now glass is not paramagnetic, it is diamagnetic. Now this glass, when I pass in the medium, in the gap, what will happen now? The ball will fall. Why it will fall? Because glass will cut the lines. Yes or no? Yes. Let us work. What happens? It doesn't fall. Why it doesn't fall? Because this is transparent. Okay, now I take a very special medium. You know what is this? Mirror, plain mirror. Now this plain mirror will reflect the magnetic field. So the moment I push the mirror in the gap, the ball will fall because it will reflect the magnetic field. Yes or no? No. Okay. Now they are smart. Now they know answer is no. Let us work out. Oh, it is transparent. Now I learn new physics. Mirror is transparent for magnetic field. Mirror is transparent for, not for light. For light, it is opaque. For light, it is opaque. And for magnetic field, it is transparent. I can push like this or like this. It doesn't fall. Now the tricky question. I have got a very thick aluminum slab, very massive, very heavy. And if I pass in the gap, what will happen? The ball will fall. Because such thickness, can it be transparent? Yes or no? It can be? Yes, it can be. Work. Really it is transparent. Really it is transparent. Very interesting. But this enjoyment comes only when you do experiments. You observe experiments. And the best way of learning science is hands-on experiments. Hands-on means you do by your own hands, and that will be your lifetime memory. People never know what is lifetime memory. I learned it today, I will not forget up to the end of my life. That is lifetime memory. But now I am having iron sheet. Iron sheet, if I pass in the gap, what will happen now? it is cut the line and fall. But see, it is not falling, it is remaining. The reason is very different. I won't say it is transparent. I won't say it is transparent. But the moment I bring the iron sheet near magnet, it gets magnetized. It is called as magnetic induction or induced magnetism. Magnetic induction or induced magnetism. And this is very funny property. Why? If there is south pole here, I get north pole here and again south pole here. Oh, the two poles up and down. And this south pole will always attract this north pole. Very simple. You cannot forget. But remember, if I take a very thick iron sheet, it may fall because the field will become weak. Because of iron, field will become weak. For example, if I take very thick like this, then it may fall. Okay? Very thick. If I keep, yes, and then I keep, no, it is not remaining. It is falling because this will make spread of light. Weakness, field will be weak. Okay. So, very different property. Now, one last question. I have shown you plenty of media, special materials. And all these materials are transparent. Okay. Now, if I take them, all of them together and push it in the gap, will the ball remain or fall? Yes, will the ball remain there or will it fall? Work out. So what we learn? All are transparent. But in between, if I insert iron, it will fall. Okay, anyway. Did you like the experiment? Yes. Next. Okay, fine. Now this is very, very special demo. This demo is not for school level. Actually, it is for college level. But I like to show. I like to show to school people because they will pick up some ideas for future. Those who are interested in science, they can learn higher level things than syllabus. And I always tell the teachers, give knowledge to the students which is beyond the books. Now I am having a very special pendulum here, and that pendulum is not ordinary pendulum. It is magnetic pendulum. You know what is this pendulum? Magnetic pendulum. Magnet. And if I give the free oscillation, I find that, oh, it is not easy. Okay. Yes, can you see the oscillations? We call it free oscillations. But now I have got a thick aluminum slab. It is not ferromagnetic, it is not magnetic because it doesn't get attraction by iron. Aluminum is not attracted by iron. But I will show you a magic now. I keep the slab over here and I confirm that this magnet is not touching the slab at all. It is freely moving in air. And then I leave it. Oh, great. Have you seen what happens? When I leave it, within 1 or 2 oscillations it will stop. Something wrong here. Why the pendulum should stop? Now, interesting question. Aluminum is not magnetic, ferromagnetic, but the ball, the pendulum will have sudden decay, stop, because it is called as magnetic break. Magnetic break? It works without contact. The two surfaces not touching each other, but automatic break, stop the motion. Are you able to understand what I say? Now, those who are able to think properly, for them, suppose I make this, and now I change my mind, I keep the slab instead of like this, I take like this. See what happens. Have you noticed the change? Have you noticed the change? Yes, what is the change?
There are more oscillations.
And now see what is the change? Yes, very fast break and is slow break. Common sense. More length is covered, less length is covered. Now let us learn secret of this experiment. Secret. Magnetic break. What is secret? When a magnet will move over this slab, this magnet will induce current in this block. And these currents are called as eddy currents. And those eddy currents, they build up their own magnetic field. And that magnetic field will oppose the motion of magnet. That magnetic field will oppose the motion of magnet. Simple. Remember one simple sense. But condition, this must be metal. And this must be thick, sizable thick. Then only large force will be developed. Otherwise not. Okay? So we are having a very special magnetic brake experiment. And now we will change over. Yes, bring it. Keep it. Okay. Can you see the light? What is this light? Laser. It is going from water to air. It is going perpendicular. So when it comes perpendicular, it goes perpendicular. No change of direction. No change of direction. Straight. But if I change the angle and make this angle say 10 degree, I make it 10, I get about 16 here. That is large. If I make it 20, I get around 30. If I make it 30, I get around 42. If I make it 40, I get around 60. Now surprisingly, this angle is small and this angle is large. Why? Why it is like this? This angle is small and this angle is large. Have you studied refraction? Have you studied refraction? In the refraction, we learn, we by heart that when a ray of light goes from denser medium to rarer medium, it will bend away from normal. Okay? Am I right? It will turn away, angle will be more. So we learn very simple basics. Angle, not equal because water, air, change of medium. Okay? Now, common sense. If I increase this, this will increase. And one position will come when for a particular value of this angle, this will become 90 degree. You know, 90 degree means this angle will be called as critical angle. Critical angle. मराठीमध्ये त्याला म्हणतात क्रांतिक कोन. क्रांतिक कोन, critical angle, very interesting phenomenon. And for water-air interface, it is 48 degree approx. Okay. So when I make this angle about 48 degree, I get this almost 90. And if I go beyond 90, beyond 48, I observe. Oh, you see what we observe? You know what is this? Anybody knows what is this? It is called as. Nobody knows. Science students. It is not in school level. It is called as total internal reflection. If you have not studied, you study it now. Total internal reflection. Now tell me why the word total? Total means 100%. Energy goes back to the same medium. Nothing comes here. Nothing comes here. Ideal phenomenon. Because water-air interface plays the role of an ideal mirror. Now what is ideal mirror? Ideal mirror is the one which reflects 100% energy back to the same medium. There is no any mirror ideal in nature. Only one mirror is water-air interface or liquid-solid, liquid-gas interface. And this is the property on which optical fiber is based. You know optical fiber? Have you studied optical fiber? Have you seen optical fiber? No? Okay, I'll show you. I have got plenty of things to show, but remember this is like this. So this angle and this angle is equal because law of reflection. So it is called a total internal reflection because the incoming ray, normal and outgoing rays are in one plane. They are in one vertical plane. That rule of reflection. So it obeys the laws of reflection. And you can see, if I make it 70, I get 70. If I make it 80, I get 80. Yeah? This 70, 70. 80, 80. Exactly equal. You know why? Laws of reflection are obeyed by this phenomenon. Okay? Now we can go other way around. I can go from air to water. Now it will be different because ray is going from rarer medium to denser medium. So when I make this angle 10, I get around 6. If I make it 20, I get around 12. If I make it 30, I get around 20. If I make it 40, I get around 30, yeah, less than 30. Now 50, 60, you know this angle is large and this angle is small. Tell me why? Why this angle is large and this is small? Refraction. But here, ray is going from rarer medium to learn through experiments. Wonderful. And why it is important? Because you can take the readings, you can make the measurements. Classic. So this apparatus will give you all phenomena very clear. For example, something is coming here also, you know. You know what is this coming here? This coming here is called as reflection, but it is called as partial reflection. It is called as partial. You know why partial? It is not total. Why partial? It is not total. I want you people to understand the words properly. Partial. If water-air interface is showing some ray coming up, it is partial. But observe the intensity here. And now observe the intensity. And now observe the intensity. What do you observe? When I increase this angle, I get more intensity. That is law in physics. Okay? Intensity depends upon angle of incidence. Fine? Now, what is the beauty of the apparatus? I can take the readings. I can take angle I, 5 degree, 10 degree, 15 degree, 20 degree, increment of 5 or 10, continuous, and for each angle, I can record R. I can make column I, R, sin R, and last column sin I upon sin R. I will find that sin I upon sin R remains constant. You know why it remains constant? Snell's law. It is the refractive index of water to air. Okay? Air to water. Refractive index, have you heard about refractive index? Madam, they are from which standard? So they know refractive index? No idea. Okay. Okay, they will learn in 10. Fine. They can see the experiment, they can remember, they can recall and make a memory. You know, very important thing is that you can take readings, you can write down table, observations and so on. This apparatus has one speciality. I can replace this water by other transparent liquid like kerosene, petrol, diesel or alcohol or benzene, toluene, and I can find I, R and mu. So I can study various liquids and their refractive indices. Also, it is called as Snell's law, sin I upon sin R. Mu is equal to sin I upon sin R. So in one apparatus I can study many things. But one more phenomena I want you to understand, that when a ray of light is coming from denser to rarer, you are getting this angle large, this angle small, but at the same time you observe something is coming here also, you know. You know what is this coming here? This coming light here is called as partial internal reflection. Surprisingly, not a single textbook mentions this property. Not a single textbook mentions this property, what is called as partial internal reflection. Every textbook mentions total internal, but nobody mentions partial internal. And this plays very important role. So this partial internal reflection is playing extremely important role. Okay? I want to tell you one interesting point. This apparatus is my own idea, design, fabrication, carpentry, assembly, in my own lab, workshop, at my residence, and I have given this a name. Very important, I have given name. The name of the apparatus is Tyroscope. I have given TIROSCOP. Now why TIR? TIR stands for Total Internal Reflection. Simple. And O stands for observation. I can observe TIR. So I can observe the total internal reflection. So I give a name Tyroscope. And when I had sent this apparatus long back, about 20 years back, in one competition of teachers competition of making teaching aids, there I got the first prize at the hands of Dr. Vasantrao Govarikar. Great scientist. And that prize is prestigious Haribau Mote Award. Haribau Mote Award is given for teachers who are making good science teaching aids. Okay, now this is very special, and I hope you are able to understand everything, but this is a bit costly. I made small copies of this using red color laser and using small acrylic assembly, and it is low cost, and I given it to many schools and colleges, and they do experiments in lab, small groups, 8 to 10 people. I will give that hands-on experiment. Okay, next. Yes, sir. Okay. We are taking 5-minute break. 5-minute break. Those who want to go to washroom or something, they can. But come back within 5 minutes. Those who want to go, they can go, but come back within 5 minutes. Please. Please take care. Okay? Everybody? Everybody is going out. Huh?
Okay, please be seated. I have a small announcement from YSDEN, Young Scientist Day. We are having a sky observation. Generally, every year we keep this sky gazing thing. Due to COVID, last 2 years we couldn't able to go for such a sky gazing event. But this year, by 21st of January, Lavadi, we are having this night sky observation. You can contact Mr. Sudhir Sirsat sir and Shirsat madam from the Marathi medium for the Lavadi sky gazing observation. गेल्या 2 वर्षामध्ये कोविडच्या कारणामुळे आपल्या शाळेला बरीच सुट्टी होती, त्यामुळे 2 वर्ष आपलं हे रात्री आपण स्काय गॅझिंग करायचं ते झालं नाही. पण ह्या वर्षी होणार आहे. तर 21 जानेवारी ला आपलं ते ठरलेलं आहे. त्याच्या संदर्भातली जास्त माहिती हवी असेल तर शिरसाट सर आणि शिरसाट मॅडम मराठी मीडियमच्या आहेत, त्यांना तुम्ही कॉन्टॅक्ट करू शकता. जस्ट 5 मिनिटचा ब्रेक आहे. ब्रेक झाल्यानंतर आपण परत सुरू करूया. थँक्यू.
Hello. Okay, start. Yes. Oh. Ready? Shall we start? Start. Okay. This is one very special instrument. Again, my own design, fabrication idea, everything homemade. You can see there is a very special setup, and you can see the laser light. Yes. Can you see the laser going straight? Fine, it is going line, straight line. But in the path, I will insert one prism. And that prism is of glass and it is put in a slot and it is push fit. You know, push fit means it will stick by friction, okay? In a slot. And I now make the laser beam to pass through this. Fine. What do you observe? What do you observe? The light is going towards the base. Tell me why it is going towards the base? Because it changes medium. How it changes? Once it will go from air to glass and then it will go from glass to air. You know, air to glass and glass to air. Teachers will enjoy showing this experiment because we get change of path. I was expecting light to come here, but it is coming here. That angle is called as angle of deviation. And that, अरे तुम्ही इकडे मुलांनो समोर बसा ना, काय भावासारखे बसा इकडे चल लवकर ये. अरे तिकडनं मी मध्ये येतो तुमच्या तुम्हाला कळत नाही का? इथे आहे ना समोर. अरे मराठी कळते की नाही? जागा रिकामी आहे, इथे बसा ना. अरे बघायची पण तुम्हाला समज नाही रे. या इकडे, या इकडे. मी मध्ये येतोय त्यांच्या तरी ते असं बघताय. काय जागा आहे ना इथे, या ना. या रेडी. नाउ you observe that when I rotate the prism table, this will go down and come up and go down. It will come up and go down. That means first increase, then decrease, decrease and increase. Okay, and that will be for clockwise, anti-clockwise rotation. You observe this very carefully. Now it is down. I turn clockwise. See what happens. It comes up and goes down. Now I turn anti-clockwise. It comes up and goes down. Again it comes up and goes down. Again it comes up and goes down. This coming up and going down is happening because the variation of angle of deviation is like this. You know, like this means first decrease and then increase, and that is called as angle of minimum deviation. And if I know angle of minimum deviation, I can tell what is the refractive index of this prism, mu. Very interesting 11th standard experiment. But this is called as vertical spectrometer. Remember some points. The refractive index of the glass is not same for different colors. For red it is minimum and for violet it is maximum. Second thing, if I pass, instead of green light, if I pass white light through prism, I will get color separation. It is called as dispersion. Color separation. And I will get spectrum. I have got beautiful spectrum. I will show you spectrum for you afterwards. But this is vertical spectrometer because in lab this spectrometer is horizontal. Because in lab there is one source of light, one collimator, one prism table, one telescope, and only one human eye can observe at a time. One human eye. But here 400 human eyes are observing. You know why? Laser. Laser is highly collimated, highly focused, large intensity, no need of collimator, no need of telescope, because on the screen I can see the track, ray diagram, beautiful. Using laser, I had done plenty of experiments about lenses, convex lens, concave mirror, convex mirror, and those experiments are really wonderful. I'll conduct one workshop for your science teachers and show them innovation, and they can pass it to the students in lab, and they can make their own apparatus. Very interesting. They can make their own apparatus, and that will be nice teaching aid. Anyway, vertical spectrometer is again my another contribution to physics. Okay, next. Yeah, whatever. Now, I have a big collection of experiments and I want to show maximum. So I speed up now. Huh? You know what is this? Empty bowl. Trikanda. Huh? The empty bowl of plastic. And what is this? Coins. I am putting the coins in this box. How many coins are there, you count? 1, 2, 3, 4. Okay? How many coins I put? 4 coins. Huh? And now I will play magic. My magic is very, very interesting. 1, 2, 3. And the coins disappear. Coins disappear. There. Great. The real magic is that coins are getting stuck to plastic, and that is magic. Can you imagine? Plastic can attract the coins? No, then what is the idea behind it? Where is magnet? Where is magnet? Nothing. No magnet. No magnet. Where is magnet? It is empty bowl.
It is going
Okay. I tell you the secret. Huh? The secret is, this is double vessel. You know double vessel? Double bowl. And between the two bowls, at the bottom, I got a thin blade-like magnet. You know, razor blade-like thin magnet, but very strong, very special, very thin magnet, like a metal plate, and that is hidden between the two bowls. Now, normally magician uses science. Plenty of things are there which are based on science, and we can imagine that this is so powerful that it can attract the coins very tight. Okay. Now, one more magic, very interesting. I got a very special camera, video camera, and I will take photograph of those people who can smile. Can you smile? Yes? Can you smile? I take a photo? Come on. Yes. I take a photo. Flash? I take a photo. Very simple. This is innovative idea. The flash works on Faraday's law of electromagnetic induction. What is the secret? Yeah. Secret of this coil, there is one coil, and inside this coil there is one strong magnet which is floating in air in the cylinder. In this cylindrical rod, hollow cylinder, a very strong magnet is floating in air. No, student ask the question, how can you keep magnet floating? How can you keep magnet floating? Very simple. One magnet here is repelling upward and one magnet is here repelling downward. So how many magnets are there? 3 magnets. Out of 3, 2 are fixed and 1 is movable. Now I will prove. Yeah, there is magnet because it is iron key. Magnet, yeah, bottom and top, very strong magnet, and in the middle also there is magnet. Inside the coil there is magnet very strong, and my keys are getting attracted there also. But funny thing, now my camera is not working, my flash is not working. See, is it working? Is it working? No. Now why it is not working? And now it is working. You see the difference? It is not working. And now it is working. What is the difference? Yes, what is the difference? I make fast movement. So if I make fast movement, the magnet will dance in the coil, up and down, jump up and down. And when the magnet will jump up and down, then only the current will be generated. Basic principle of generating current. I should have magnet, I should have coil, and between magnet and coil there should be relative motion. Yeah? But if I make slow motion, it doesn't work because in slow motion, magnet 1, 2, 3 and coil all are going at the same speed up and down. So there is no relative motion between coil and magnet. Students never understand what is relative motion. You know what is relative motion? I tell you simple word. You keep the magnet fixed and move the coil, okay. Or you keep the coil fixed and move the magnet, okay. Or you move both but at different speed, okay. Are you able to understand my words? I repeat, those who are not able to pick up, please pick up. You can keep the magnet fixed and move the coil. Second thing, you can fix the coil and move the magnet. Or you can move both, but at different speeds, because when I make vibrations, my magnet is jumping up and down by inertia. Oh, that is very important, inertia. And that is why you are getting current. And if I make it fast, I get heavy current. And if I make it slow, you see now, slow motion, it is not heavy current, right? Fine. So this is again my own design idea. Everything is very simple and yeah, I would like to show one, two, three, come on. What is this? Ring magnet. Okay, what is this? Oh, floating in air. Why it is floating in air? Repulsion. Like pole. North pole facing each other. Fine. Now if I keep one more magnet, so that also is floating. Two are floating. Because it is north, south. Facing like pole. Okay, now check. I take this out and inward. Attraction. I take this up and inward. Repulsion. Observe carefully. I take this up and inward. Repulsion. I take this up and inward. Again repulsion. No attraction. Huh? See? I take this up and inward. What I did? I made double inversion. Anyway, the real magic comes now. This is attraction. I take it up and inward. Attraction. I take it up and inward. Attraction. No repulsion. Funny. Magic. See, I take it up and inward. Only one inversion. And attraction again. And take it up and invert. Again, attraction. How? This is not a magnet. Correct. this is not a magnet. I call it zero bore magnet. Okay? What is this? Zero bore. You know what is that? Demagnetized. Now my student asked me how you demagnetize magnet. Simple. If you want to demagnetize, you hammer it by hammer. Just hit it. Or you keep it in a hot furnace, bhatti, and you make high temperature, like 600 degrees centigrade. It will lose memory. Total memory loss. And the magnet will get demagnetized. And that is called a Curie point, and when you pull it back, it has forgotten its property of magnetism. Are you able to understand it? We learn this in 11-12 standard. Curie point. But students have good memory. They will remember 11-12. Very easy, no? Now, I will ask you one question. How much time is there? Exact, somebody? Please tell me time bar. When students will feel like stopping, you can tell me. You want to stop me, you can stop me. Alright. Now, I want to ask you a question. This magnet is floating in air, okay? My question is very simple. I got a two-pan balance. You know two-pan balance? Two-pan balance. In one pan, I keep this and I keep 100 gram in other pan. I get level. So what is mass of this? 100 gram. Now I keep this magnet and I keep 100 gram more. I get balance. So what is total? 200 gram. Then I keep this and again 100 gram added. So I get 300. Okay. Now my question is, I keep this in one pan, keep this magnet like this. What should be weight in the other pan to balance? Think about it. I repeat my question. In one pan, I am keeping this and magnet like this. What should we weight in other pan to balance this? To make a level? Yes? 200. How many people say 200 is your right? They are doubtful. How many people say 200? You say 200. Okay, you say 200. Any other answer? Yes? What is it? 200. Any other answer? Audience? Yes? Loudly. Huh?
No need to add.
What should be weight in other pan to make the balance? Tell me the number. Tell me the number. Okay, I'll give you option. One option is 200, one option is 250, and one option is 300. 200, 250. Okay, 250. Now one more option is 300. 250. Anyway, I avoid waste of time. The answer is 300 grams. I was expecting some students to give the answer 300 because common sense. See the common sense. In one pan, I keep 1, 2, 3. Total mass is 300 grams. So other pan must be 300. Now people argue that this is floating in air. It is weightless. No weight. Floating in air means no weight. So it should be 200. And 200 is logical answer because it is having weightless state. But concept is wrong. Many people never understand this concept because they don't know Newton's laws. Newton's law says action and reaction are equal and opposite. I'll tell you what is action reaction now. When this magnet is floating in air, please concentrate, attention, full. Teachers, take care of students, let them remain complete silent because it is essential statement. When this magnet is floating in air, I ask why it is floating. People say because this magnet is pushing this magnet up by the same force as mg. Mg means weight. So this weight is balanced by magnetic force. Agreed. Agreed. Weight is balanced by magnetic force. But at the same time, when this is experiencing the upward thrust, same time this magnet also is experiencing downward thrust. And that downward is 100 gram. Invisible and without contact. In magnetism, everything appears magic because without contact, they interact. Magnets interact without contact. Funniest statement. Magnets interact without contact. Fine. Now I tell you one more thing. I went to the school of blind students and told them, hold this, and told them this is 100 grams. They said okay. Now I told them this is 200 grams. They say okay. Now I said it's 300. Okay. Now I take it up and like this, tell me how much weight this 300. Because blind people are very sensitive for weight, force. You know, they can say 300 because they sense the weight. You are not able to sense because you are observing only. But when you do hands-on experiment, you will understand what I am saying. Second thing, I want to lift this magnet. How much force I have to apply? 100 gram weight. But if I want to lift this, now I have to apply double. Because along with this, I have to lift this also. So I have to apply double. So always remember one statement that when this magnet is floating up, it is because this is repelling it upward. At the same time, this is pushing this downward. And that downward force is 100 gram weight. So the total answer is 300. And one chemistry statement is very important. You can neither create or destroy the mass. So total mass kept in one pan is 300 grams, so other pan must be 300. No need of physics, only chemistry. You can understand, no? Yeah. You can't create or destroy mass. Okay? Weight, yes, weight, you can see weightless, okay. But that is because of action reaction, fine. Anyway, next. Globe. Thank you. Okay, quick experiment. This is very simple collection of pipes. You know, pipe 1, 2, 3. You are having big diameter, medium and small size diameter. And we are having a very powerful magnet here. And this magnet, when I am making to have a free fall, you know what is free fall? Yes, what is free fall? Under gravity. 1 meter distance in free fall is covered within half second. How much time is required? Half second, 0.5 second approx. So the moment I drop this magnet within half second it falls. And I can't count half second very easily. But if I make the magnet to fall through this pipe, which is aluminum, not magnetic, paramagnetic, very weak interaction. So if I make this magnet to pass through this pipe, it will not fall within half second, but it may require 2 or 3 seconds. I can count 2 or 3 seconds. You know how to count seconds. Counting second is an art. See, 1, 2, 3. Within 2 and 3 it falls. Check. 1, 2, 3. Between 2 and 3 it falls. Okay. Now I change the pipe, and this is less diameter, medium size. Now I make the magnet fall. 1, 2, 3, 4, 5, 6. How much? About 5 to 6. Okay, check. Repeat. 1, 2, 3, 4, 5, 6. Again, repeat. Check. 1, 2, 3, 4, 5, 6. Very simple. Now I change the pipe. This diameter is 12 millimeter and this diameter is 10 millimeter. So gap of 2 mm is enough for magnet to pass. Now I am making the magnet to pass through this pipe and I count the seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, somewhere between 11 12. I'll check again. Okay? Don't count fast. Be slow. Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? 11. I repeat. Check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I made slow counting. Anyway, learn one thing, that proper counting is done by stopwatch. And that stopwatch should have least count of 0.1 second or less than that. That means it should be accurate counting. Okay? I am making rough. But question is, why the magnet will have a slow fall in this pipe and rapid fall in this pipe. So 2 seconds, 6 seconds, 11 seconds, why different? Because the basic concept is there. Listen, very important statement. Michael Faraday did the pioneer experiment in science. He took a copper coil and he pushed the magnet through this coil. When he pushed the magnet through this coil, he found current in coil and that current will generate magnetic field and that magnetic field will oppose the motion of magnet. Same thing happens here. That is, when magnet is passing through this pipe, currents are induced. They are called as eddy current. And these currents will generate magnetic field that will oppose the motion. But in bigger pipe and smaller pipe, time difference comes because the distance between magnet and pipe is large and here distance between magnet and pipe is small. So at a small distance, you get strong magnetic field. Are you able to understand what I say? At a short distance, very strong magnetic field comes and at a long distance, so if I take a pipe bigger than this diameter, it will have almost free fall. Are you able to understand? But conditions, there must be metal pipe. And if you take copper or silver or gold, it is still better because they are more conducting. Aluminum is force. Anyway, start with, okay, take this away. Mandir. लाइट ऑफ करते का थोड़ी लाइट ऑफ कर सके ऑफ के लेगा लाइट ऑफ है लाइट खाना ऑफ के लेगा जरा ऑन करा
याच्यावरती
हाँ ओके टेक केयर ऑल ऑफ यू साइलेंट प्लीज I have a globe which is generating sparks, and if I bring the tester near, you see what happens here. Tester is glowing. The glow of the tester indicates that there is very high voltage, very high danger. The tester is on. That means if I touch this globe, I will get terrible shock. Common understanding of tester, but it is a wrong concept. I prove that I can touch the globe and I won't get any shock. You can see on the other hand, when I touch the globe, I will collect all the sparks and take it in my body. And my body is very good conductor. Are you getting this? Okay, fine. Now one more magic is there. I have a tube light. Now I am making half tube light. I am making half. Now this is very interesting experiment, and we have a tester like this, but even if I keep the tester inverted with metal in my hand, it glows. Now that is very funny. How you hold metal and make the tester glow? The reason is very simple. This globe is emitting electromagnetic waves, and these electromagnetic waves or photons, they are captured by the neon tube inside this neon bulb, and neon bulb is getting light, excitations. Same thing, inside this tube light, there is vacuum, and in vacuum mercury vapors are there, and they get energy and they get glow. And that white powder will make visible light, because without white powder, lot of ultraviolet will come out. And if you see that ultraviolet, you will become blind. So never have a tube light without powder. Yeah, without powder, no tube light. Huh? Powder is a must, because that will absorb the ultraviolet and emit visible light, and it is called as wavelength shifter. It will shift the wavelength, it will shift the frequency. Very interesting demo experiment. You can see the tube light, you can see the neon bulb, and you can see the spark, and my body is good conductor. I can carry the spark. Now people ask me question that when you touch, why you are not getting shock? Why you are not getting shock? The answer is very simple. The current which goes into my body is a few microamperes or a few tenths of microamperes. The current is very, very small, and such small current my body can tolerate. I can conduct without shock. Very interesting phenomenon. So I can carry the current of a few microamperes or a few tenths of microamperes. That is 10, 20, 30, up to 100 microampere, yes, no problem. If you go beyond 100, say 1000 microampere, milliampere, yes. If you get a current of milliampere, you will get a shock. And if you take a current of ampere, you will get heaven. Direct. Lights on. Now, let us learn science behind it. I like people who can pick up very fast. Pick up very fast. What I say, you should record in your mind, understand, analyze, and then discuss. Okay? Now, students ask me question, sir, tell me what is inside this globe. What is inside the globe? I say nothing. Vacuum. What is inside the globe? Vacuum. And in that vacuum, there is a small mixture of helium, neon, argon like inert gases filled at very low pressure. Atmospheric pressure is 76 centimeter of mercury column, but this filling of inert gas is 1 or 2 millimeter of mercury column, very low pressure. So if you fill the vacuum by very low pressure inert gases, you can generate plasma. Plasma. Plasma is the fourth state of matter, solid, liquid, gas, and plasma. And this discharge is called as single electrode discharge. Actually, this is topic of our MSc level, master level, but I tell students to remember this. Single electrode discharge was the concept given by Nikola Tesla. Nikola, yes, there Stop talking. I can't tolerate. Please stop talking. Concentrate here. I tell the teachers, keep the look. Keep on watching the students. If they are talking, send them out. Because this is not fun. It is science. Inside there is vacuum. And in vacuum, gas filling is there at low pressure. Which gas? Helium, neon, argon. Inert gas. Now, in the center, there is one electrode. You know what is that electrode? Electrode is one metallic conducting rod which has very high voltage and high frequency, AC, alternating current. No? In physics, we say very high voltage, very high frequency has no meaning unless you give the number. I will give the number. The voltage on the electrode is about 10,000 to 20,000 volt. Can you imagine 10,000? Your AC mains is how much, you know? AC mains is 230 volt. AC mains is 230 volt and that is 50 cycle per second. But inside this electrode is 10,000 to 20,000 volt and the frequency is about 30 to 40 kilohertz. 30 to 40,000 cycles per second. So such a high voltage, such a high frequency, if you give to single electrode, it will discharge, it will throw away electromagnetic waves. And those electromagnetic waves will ionize these gases and generate sparks. So this spark is nothing but discharge. Now, many students ask this question again and again, that when sparks are going all around, why they are going all around? The reason is very simple. Inside one electrode is there and the glass globe will play the role of second electrode. The glass globe will play the role of second electrode along with surrounding air. Yes, surrounding air also plays important role in conducting the charges, ionizations. But the moment I touch, I get spark in my body. Why? The reason is my body is much better conductor than the surrounding air. I hope you are able to understand my statement. Are you able to understand what I say? My body is much better conductor than the surrounding air. So what is the property of charges? Property is to jump towards the lowest ohmic path or best conducting path. In sky, when there is thundering, lightning falls, spark comes down, it comes on a tree or a tower or tall building. You know why? Short circuit path, lowest ohmic path, conductive path. And to protect your building, some special arrangements are made. Have you heard about it? Protection from thundering, lightning. Yes. There are plenty of things to learn. But I repeat my statements. Those who are not attentive, they can remember now. Inside this globe, there is electrode having high voltage, 10,000 to 20,000 volt, high frequency, 30 to 40 kilohertz, and high vacuum and gas filling at low pressure. Are you getting all points clear? So globe is very important, very delicate. You touch, you get no shock, very less current flow. And this glows because neon bulb is there that gets energy from this electromagnetic wave. And this glows because mercury will get excitations. I have given main points. Any doubt you have, you can ask me. If you have any doubt, you can ask me. But this is MSc level experiment. Now people ask why you are showing MSc level experiment to your school level people? Because I am sure they can understand what I say, they can memorize what I say, and they can learn with more interest in science. Yes, they can learn with more interest in science. Now, I will show you one more experiment, and that is based upon another advanced technology. Take it away. Okay. This is another interesting device, very interesting device. And this is working on AC mains again. Yes. Can you see what is this? LED, light emitting diode. Chain of LEDs with switching on off. And you see the changing color. But this is magical device, and the magic is so powerful that if I keep it in water, within 1 second the water will start boiling. 1 second. See, 1, 2, 3. Yes, it is boiling. See this boiling water? Yes, it is boiling. Can you see the boiling water? Yes. Very hot. If I put my hand, terrible, thermal shock. Hot touch. So you don't have daring to put your hand in boiling water, correct? But I can concentrate my willpower and I can lift the machine and take it out without any problem. See, my willpower. 1, 2, 3. Oh, very hot. Tremendous hot. But my willpower is there. My willpower is very strong. He says no. Why you say no? You know? Anybody know this? Okay, I'll say again. 1, 2, 3. See, it is boiling. And if I put my hand, I'll get hot. Hot touch. Thermal shock. 1. Willpower. 1, 2, 3. You want to try? I'll teach you magic. You want to try? Are everybody okay? Yeah. Okay, 1 by 1 go. Stand here. First boy, then girl. Hey, wait. I will give you my magic. Second. Okay, now I have given you my magic in your hand. And now you can put your hand in boiling water. Now you can put your hand in boiling water. Okay? It is hot. Arey what? Very smart. Very smart. Okay. Whatever. Current. He got the current, गरम है, ठंडा है. That is my magic. Your boiling water is cold for you. That is the magic. Now you can. Hi. Gabali. She is saying it is cold. It is boiling water and you are saying it is cold. That is my magic. That is my magic. Freeze water. Okay. Very cold water, freeze water. You want to see? Oh. Very good. So now I will tell you secret. Yes. Everybody will not get chance. Sorry. You want to learn more? No? Please. Cooperate. Please cooperate. Please cooperate. This machine is a very special creation. Stop. Boys, girls, please attention. I will not talk much. Madam, leave it. Leave it. माफ करो. Attention here. This machine is very special creation. Inside this machine there is one vibrator, oscillator, and that is generating frequency, high frequency vibration, such a high that you cannot hear. Your range is 20,000 cycle per second, audio range, upper limit, and it is 25 to 30,000 cycles, so it is called as ultrasonic wave. And when you put ultrasonic wave with the help of diaphragm or a membrane in water, water will start jumping up and down at high speed, and water molecule will be separated, and that is called as evaporation. You know what you are observing? You are observing is not boiling, it is evaporation, vaporization. This evaporation can occur at any temperature. Very interesting. Sea water evaporates, goes up in the cloud, and rainfall comes. Yes, it is water cycle. I will show you water cycle here. This is dense vapor, and this is called a cloud. And this cloud will give me rainfall on the table. Have you seen the cloud? And if I keep my hand here, and if the cloud is over my hand, I get droplets. Tiny droplets. That is the rainfall. Exactly what happens, in kitchen, when you see boiling water for a cup of tea, the steam goes up and up, vanishes in the air. But here, it is not like that. Can you observe what is happening here? The vapors are dense than air, so they are not going up, but they are lingering around. If I take a bigger pot, I can make a bigger cloud, but for your satisfaction, have you seen the cloud? Yeah, I get rainfall here. Yes, I feel droplets, and on table it is raining. And my question is, sea water is salty and dirty, but the rainwater is clean and sweet. Why? No salt. Why? Because the salt cannot evaporate. Salt cannot go up with in the cloud. Okay? So the cloud will give you pure water, distilled water. Yeah, I like distilled water. But in some places, acidic rainfall comes. You know why? Why acidic rainfall comes?
The acid mixes in the
Huh?
acids.
Acid rains. Why? Why acid rains are there? Yes?
Sir, the pollution emitting from the factories, they mix up the
Which gas?
NO2.
Okay, nitrogen,
Sulfuric acid also.
NO2, H2S, SO2, sulfur dioxide. There are some gases which are in the air, and when rain falls, they get dissolved in water, and we get acid rains. Very dangerous. Very dangerous, acid rains. But it occurs only in highly polluted areas. You can see again. Have you seen the cloud? Yes. There is rainfall. Now, question is, what is the name of this apparatus? This apparatus is called an ultrasonic atomizer. Remember the word. Ultrasonic atomizer. Why? Because it has got ultrasonic vibrator, and it converts liquid to gas. It is called as atomizer. Separation of molecule, atomizer, fine. When you use spray or a pump and spray, it is atomizer. Atomizer is very common term. Okay. Next. Oh, here is one more interesting magic where we can learn that there is something concerned with. You see what is this? A glass bulb, a tube, and base. Okay. Ram there, Mr. Book. Now I have put my hand and see the magic. Very powerful magic. What I do? I am pressing the glass bulb, and the water is rising up. Now I have pressed the upper bulb, And funny point is that water will go down. Liquid will go down. Again, check. I am pressing the glass bulb and the water is going up. Can you compress the glass bulb? No. Then why it is going up?
Body temperature.
Okay. Body temperature. How much is our body temperature normally? 37 degree. Okay. In the hand it may be 35, 36 degree. In the inside it is 37. Now, the boiling point of liquid inside is about 15 to 20 degrees centigrade. 15 to 20 degrees centigrade, in that range, the boiling point is there. So by my body touch, by the touch of my body, the water will start boiling. Now when the water will start boiling, see what happens here. I will tell you phenomenon. In the lower bulb, if the water will start boiling, the liquid will go into gas. But when liquid goes into gas, there is lot of increase in volume. So this volume increase is not possible here. So pressure is generated. And because of pressure, it rises in the glass tube. And you can see the going up. Okay? And when I, okay, one more thing to remember. There is partial vacuum here. Partial vacuum, not total vacuum. Huh? And if I hold the upper bulb, we find that the glass, the liquid is going down. But I want to show you all magic. What I do, I keep it on the table and tell the liquid to start rising. Come on, start rising. Start rising, start rising. Go up, come on, go up. And more, and more. See, obey my order. It goes up. Magic. Okay, now I will say, come on, start going down and go down. It's gone. Now again, I will take order. Come on. Start rising up. Start rising up. Start rising up. It is rising up. How come it is happening like this? Huh? Okay. But it is same here and here.
Touching down.
No difference of temperature. But my magic is there. Yes? This is also same, this is also same. But how it rises up? The reason is I use water to cool this surface, and if this surface is cold, it is bound to rise up. You know, high temperature, low temperature. See, it is rising, correct? Now you can see. Now you can see I am not putting it down, but I am making this to go down. I am making it go down and holding it like this, and then tell, come on, start rising up. Start rising up, start rising up. Go up, and more, and more. It goes up. Magic. Actually, it is cold and it is hot. It is called as love thermometer. What is the name? LOVE, love thermometer. And what is the liquid inside? Liquid inside is either chloroform or alcohol, low boiling point. And the boiling point is low because of vacuum, partial vacuum. It is because of partial vacuum. Okay. Yes, I am having a very special tube light in my hand. You know tube light? Okay? Coil open. Some more open. Yes, can you see? Can you see what happens here? थोड़े या साइड में या दिशेला जरा दाखवा. Can you see what happens here? Okay, या दिशेला दाखवा. Okay, you are getting spectrum, color, and if this is mercury tube light, you will get beautiful color lines that I show in junior college tables. For junior college people, you can get beautiful line spectrum for mercury. But you can see the band, you know, color band. Which colors you can recognize? VIB, GYOR. Yes? Same thing you can see with the LED. Can you bring LED? Bring that yellow LED. Yeah. Hold it. Hold it. You know what is this? This is one table lamp. Very simple one. Can you see the light? Can you see the light? Now can you see the light? Yes. इकडे दाखवा. एकदा इकडे दाखवा. या मुलांना दाखवा. काय दिसतंय बघा? What do you see? Yes. What do you see? आता या साईडला दाखवा. Are you able to see? What do you observe? Beautiful color band, and that is called as spectrum, and this is called as diffraction grating. Diffraction grating is a very special thin film, and that thin film is so funny that in this film there are vertical lines, small, very tiny lines. And how many lines? In 1 millimeter, there are 1,000 lines. You know what is 1 millimeter? Small. In such a small distance, there are 1,000 lines. So if you have 1,000 lines per millimeter, and this length is about 50 to 60 centimeters, so there are so many lines, all vertical parallel, and this is very special imported thin film, very costly, bit costly. It will cost you 300 rupees. Single film 300 rupees, because it is very special diffraction grating, and it is used for studying spectrum in various objects. Okay? Put it back. Yeah. Huh? Sir, time किती आहे सांगा जरा. I will have to. हाँ? 11:15. Okay. 15 मिनट. Quick. सेपरेट कर. हाँ? त्यांची बस आहे, त्यांना जायचं आहे बस. मला त्यांनी सांगितलं बस आहे 12:10ची. ओके. Separate कर. This is a hammer. Okay, leave it. This is my stand. This is my hammer. This is wooden plank, and this is a hook. You know hook. Hook is very important here, and that hook can hold this hammer by just like hang. You know, it is hanged. I am hanging this hammer, and it is supported at the tip here, and I keep this hammer floating in air like this. Magic. See the magic. The hammer is tilted, wooden plank is on this side, and it is remaining equilibrium, balancing. How? By learn science behind it. Very simple science behind it, very simple. But I am making magic out of it. What magic is there? I pull this plank on this side. I pull it on this side. See? I pull it on this side. Not falling. I pull it on this side. Not falling. I pull it on this side. It is balancing, and it is oscillating like pendulum but not falling. Now people ask why it is not falling. Why the hammer is not falling? The answer is in physics, mechanics. What is the answer? The center of mass of this whole assembly is somewhere here. And if the plumb line from the supporting point, plumb line, passes through the center of mass, the body can remain in equilibrium. I repeat a statement, scientific statement, very important. Center of mass is vertically below this supporting point. Supporting point is here. But why it will oscillate but not fall? Because some friction is there. And because of friction, it can hold. Very, very important. Friction is there, it can hold. But if I take very much away and extremely thin, it may fall. It may fall because friction may not be enough to balance that force. But remember, plank, hammer, heavy side, light side, balancing, everything is mechanics. But I had done one important modification here. Now, because my students asked me, where is the center of mass? Where is the center of mass of this hammer? I tell the answer, center of mass of this hammer is somewhere on this plumb line, plumb line. Where is plumb line going? Through the rod, center of the rod, okay. But on this plumb line, there are so many points, infinite number of points. So where is the center of mass? I have found very simple trick to locate the center of mass. That is my contribution to physics. Very simple. You can see how I can do it. I take a magnet and hang the hammer by magnet. Okay, powerful magnet, neodymium. Neodymium magnet, and then I take a plumb line. You see what? You see my plumb line? Yes, plumb line concept. And I hold the plumb line here. I can imagine it is passing through the center line somewhere. And I can hold a hammer by this end also. I can put a plumb line and I note where is the intersection of three plumb lines. And that intersection is center of mass. Are you able to guess what I am telling? Yes, it is very important concept. Maybe somewhat higher level, but you can pick up. And the best way to pick up is, if I know where is center of mass, I can drill a hole, and through this hole, I can pass a screwdriver, and I can make a axis, and I can give rotations to hammer. Now my hammer is rotating without falling and balanced. You know why balanced? Because the axis is passing through center of mass. But a simple concept, very easy concept. Center of mass means moments of this and this are balanced. And if the moments are balanced, then it can have free rotation. But I dig a hole not through center of mass but some other point here. And then I observe it is not balancing. Why? Why not balancing? Because heavy side, light side, moments are not balanced. Now where is center of mass of this? Here. So center of mass is below. Yes, that's all. Very simple physics. But I have made experiment to explain what is center of mass concept. Did you like the experiment? Yes. Okay, want to see more? Yes. Still? Okay. This is one utensil having the water. I made it empty and I keep it on the table. I have a magic stick. I put a magic 1, 2, 3 and in the empty bowl I can generate water and see I am making generation of water ready. Now it is empty. Again I keep it on the table and generate water. Real magic. I am generating water. Creating water by magic. Yes, it is ready. Want to have more water? Yes, I can give you. 1, 2, 3. I can give you as much water as you want. How much you want, I'll give you. Okay? Yes? Right? Again. One more? Okay. I can make 100 times, no problem. I can generate water non-stop. Real magic, yeah. Yeah, that is, she is asking how it is possible. She is giving proper expression how it is possible. Yes. 1, 2, 3. And that is real magic. How many times? Yes. I will give you non-stop. Want to have more? Okay. 1, 2, 3. Right? Now some people say, don't keep it on the table, keep it in the air and bring the water. I say, yes, I can do it. You want to see the water coming out? Come on. 1, 2, 3. See this water. Rising. Empty bowl. For empty bowl, I will drink water. You want to see? Come here. Everybody. Both of you. Not boys. Madam. You know, many people get engrossed by magic, but science is there behind it. You can see what is inside. Inside this utensil there is a glass. Lota. एक पेला है. Glass means not glass, not actual glass. It is pail of water. Aluminum, stainless steel. Inside, outside, double bowl. You know it is called a double vessel. Okay. Now the double vessel is very. Please stop talking. I don't tolerate. Please. What do you want? This is double vessel. Inside one vessel, outside one vessel, and one hole is there. And through this hole, air can go in or come out. And the whole thing is that I can make the water out. It appears non-stop, but somewhere it will stop. Because common sense, if you put 1 liter water, you can't take out 10 liter water. Use common sense. If you have 1 liter water, you can't take out 10 liter water out of it. Otherwise, you will solve the problem of water. Water crisis will be solved. Generating water by magic is not possible. But basic concept is that you know how to start with the magic. First, you have to fill the glass. See what I have to do? You have to fill the glass. Now you fill the glass, you will find the level goes down and down. Why it goes down? Because the glass will go through the bottom hole outside. So it will come in the outer jacket. And when it comes in the outer jacket, the level of water will go on increasing. But when this and that level will be equal, no more flow will be there. So put some more water and wait for a minute. Very easy. What happens there? It goes down. Keep on pouring water. But one moment will come when from this hole there will be overflow. Yeah, people should understand overflow. When level is crossed, it will start going out, and that is overflow vessel. Okay, so I have put maximum water here now. Right, as per capacity, and say 1 liter capacity is there. So I can't take 10 liters from 1 liter, Common sense. If you have scientific mind, you will never get carried by magic. There is nothing like magic. Okay. Now it is almost filled. Now some more water? Yes. I can put some more water. Yeah. Yes, what happened there? It is coming out through that hole. Now, how to do the magic? See the trick. Magic is very, very important. I first tell the bowl is empty now. Okay? Utensil is empty. And I keep it on the table and then I take magic and see what happens now. What happens now? It is coming up.
Coming up on the
Tell me why it is coming up. Why it is coming up? Madam, remember this statement. Outside level is high. Inside level is low. Water goes from high level to simple. You explain the students by drawing a diagram in your class, they will be happy. I told teacher, you know why teacher? Because they can convey the message to students. Many students will like to see this actually, but it will be noisy, very havoc will be there. So please have patience. Yeah, hands-on experiments are required for that only. Anyway, when you have this hole, always put your thumb on this hole. Always. And pour the water and tell them now it is empty. Okay, it's not empty. Inside what is there. And when you remove the thumb, you get outlet. That's all. But when water comes out, air will go inside through the hole. You know why? If the air doesn't go inside, this cannot come out. You know why? Vacuum will be created. Yes, again it will come. You keep it. Again it will come. As long as level is high, it will come inside. Very simple. So what we learn? We learn that water flows from high level to low level if the two vessels are connected. That is very important. This vessel and this vessel, if they are connected at the bottom, water will go from high level to low level. But a point will come when both the levels will be equal. Then what will happen? Stop. That's right. Okay? Want to see more experiments? Yes, sir. How many more? One more. Okay. Take. I got many. But you want have a quick? Okay. This is a blade. A blade is there. I cannot make it to stand vertical. But I will train this. I will coach this top to stand vertical. And you can see it is standing vertical. It is standing vertical. I take it up, I make the changes, rotation, and I again keep it up, stand vertical. It has memory. It is standing vertical with some memory. Anyway, secret is that inside flywheel is there and rotation is there, and rotation will give stability. Okay? Rotation will give stability. That's all. One more. Very interesting. Top. Handle. Nylon thread. Winding. And now spin. Oh, beautiful. Can you see the top? Can you see it spinning? Can you see it standing vertical? And very smooth? Oh, it's lasting for a long time. Very long time. Not falling. Perfect balance. See, it is standing vertical. It looks like magic. No? Spinning top without top. See? Beautiful. Very nice. See this? Long time, very long time. Okay. Now, within 2 minutes, all will be scientists. Within 2 minutes. Listen carefully. I am giving you a tip. My students ask, sir, why this top is standing so much long time? Why it keeps on spinning long time? I give you 5 points. Those who are talented will remember 5 points. Those who are less talented will remember 4 points. But at least 1 point you should remember. And that first point is there is very, very less friction at the bottom and the plate. So I can make the top to go by my spin motion of my hand, finger. I can make the top to spin and I can make it vertical, okay. But by this, I can't make it vertical, no? So that problem is there. But I'll tell you further reason. When I spin this and leave it here, surface is very smooth, polished. So friction with air is minimized. Aerodynamic principle. Air friction is minimized by smooth surface. Third reason is very important. This top is having perfect symmetry. Same mass in all directions about the axis. See, balanced top. If I take a nail, hammer a nail here and then spin this top, you know what will happen? It will wobble. Why? Nail side will be heavy. So uneven distribution, unbalanced distribution of mass. In that case, it will not remain vertical. Okay. So third point is symmetry. Fourth point, very important. When I give the motion, I use the handle, and using handle I fix the axis. When children play the top, they take a top, find a thread cord and throw the top and pull the cord. So when you throw the top and pull the cord, the top goes round like this. It doesn't have one position spin. But my handle is extremely important because I am giving it a fixed axis. Very few people understand this. Axis fixing is very essential to make the stability. And the fifth is very difficult to understand. I'll tell you in nutshell that using this nylon thread, when I give some 10 turns and pull, I apply large force and that will generate large torque and that will generate large angular velocity and angular momentum and rotational kinetic energy and all will conserve. Momentum and energy will conserve. So it remains spinning for a long time. See how much science it is. I'll repeat 5 points. I'll repeat. Number 1, friction is minimized. Second, air friction is minimized. Third reason, perfect symmetry. Fourth reason, axis fixed. And fifth reason, large tools. Simple. Very simple. Thank you. Yeah.
Such a great treat for us in the new year from Sir. Thank you very much, Sir. Thank you so much. Great round of applause. Myself, Mrs. Sarita Khairnar, on behalf of Adarsh Vidya Prasarak Sanstha's, Adarsh Vidya Mandir English Medium and Marathi Medium, that I would like to thank that we have the guest speaker, Professor Bhagwan Chakradeo Sir. Really, the topics, demonstrations, activities covered by Sir and team will really portray the scientific approach and really will develop to enhance conceptual understanding. The basic science, really we got a great information, basic science information. My sincere thanks to our management of our school for encouragement of the students. I extend blissful thanks for the Adarsh College for each and every arrangement in the auditorium. I extend my thanks to our respected HM of our school who had taken great efforts to make this program. I must thank all the teaching and non-teaching staff who are always with their helping hands. I want to thank to Mr. Kiran Bhalirav sir for a live stream. Thank you very much, sir. And once again, I thank everyone for their cooperation in making today's program a great success.
Hello. One thing. I really feel very happy. I rarely get such a nice audience.
Thank you, sir.
Very nice audience and really good students. Most of them are interested in learning science. Very good. It is nice. Your mics are good and your setup is also good. Your teachers are very cooperative. They are observing discipline. Rarely seen phenomenon nowadays. And after pandemic period, students have lost the habit of sitting for 2 hours. So today I feel happy because they are attending for almost 2.5 hours. Right? Thank you very much.
ॲक्च्युली सरांनी सांगितलं की तुम्ही 2.5 hours बसलेले आहात. सरांचं म्हणजे आम्ही फार सरांपेक्षा खूप छोटे आहोत, पण सर रिअली हॅट्स ऑफ टू यू. आम्ही टीचर असून एवढे कंटिन्युअसली 2.5 तास 3 तास आणि तुम्ही ह्या वयामध्ये ते डेडिकेशन आणि नॉलेज रिअली आज जागतिक युवा दिन राष्ट्रीय युवा दिन आणि खरंच युवांना लाभेल असं सरांचं मार्गदर्शन आपल्याला लाभलेलं आहे. त्यामुळे सरांसाठी पुन्हा एकदा सर्वांनी दोन्ही हात थँक्यू सर.
Students, as per teacher's instruction, you will leave the auditorium. Till that, you will wait.